So let's look at our next problem. It says we're looking at Jack's money. He has a certificate of deposit compounded quarterly. So we know that, again, we have to use the formula A times P times quantity 1 plus R over N raised to the NT. So let's see what we have. They tell us the percent is 0.5, so we fill that in the rate spot as 0.05, right? They tell us his initial amount, P, so we had that, is $3,000. They tell us that it's compounded quarterly, so the N, there's 4 quarters in a dollar, 4 quarters in a year, right? And it says how much money will he have on his 16th birthday. Okay, so if his grandparents put in on his 6th birthday, from 6 to his 16th birthday, that would be 10 years, right? So when we plug all those in, 3,000 times quantity 1 plus 0.05 over 4 raised to the 10 times 4, we get $4,930.86. So it grew from 3,000 after 10 years to 4,930.86. And just remember to use order of operations. So 10 times 4 is 40. You do parentheses value, raised to the 40, enter, and then you multiply by the 3,000. Okay, let's look at the next one. So for this problem, it says that Jack wanted to have 7,000. He wanted to have, doesn't mean he starts with. So his final amount that he wanted was 7,000. Again, not P. The A is 7,000. So we put 7,000 right here. So we don't know what his principal is. That's why we just have to leave it as a variable. It says that we want to know if it's growing. So this is the same problem as up here. So we know that the R is 0.05, right, the rate. And we know that T is 10. We know that N is 4. So again, we have the same exact problem. We're just trying to solve for P. Because if he wants a final amount of 7,000, we need to know what his principal, what his grandparents would have needed to put in the account initially. So we first, if it's P times a quantity, right, we know we have to do 10 times 4 is 40, right? We'd have to do 1.0125 raised to the 40th, which is about 1.64. If it's P times 1.64, we can divide both sides by 1.644. And 7,000 divided by 1.644 would be 4,258.89. So that means the principal, or the amount his grandparents would have needed to put in initially, would have been $4,258.89 for it to grow to a final amount of 7,000. So let's look at number 3. This is going to be the last one they need to fill in and submit. So suppose you've invested $750. So we know that the initial amount that you invest, P, is $750, not the final amount, not A. If you're investing 7%, we know if we move the decimal 2 to the left, the R value would be 0.07. We don't know T, so we just write T as in time, right? Come up with a general formula. Now, keyword, if it says continuous, that's when you use A equals P times E raised to the RT. The only time you use A equals P times E raised to the RT is when it says continuous. Otherwise, you go with that other formula. Now, let's look at this, see what we can fill in. We know in the P spot, the principal is $750. E is a number, so you just leave it as E, right? E is about 2.714. And then the R, right, it's raised to the RT, the R is 0.07, and then your T, you don't know, T years. All of these, remember, 750 is a number, E is a number, R is a number, so you should only have one variable, one unknown on the right side. So next it says how much money after 1 year. So we plug 1 into the T spot. So 0.07 times 1 is 0.07. On your calculator, you have the E button, so you do E raised to the 0.07, and then you get that value and multiply by 750, and you end up with $804.38. If you can't find the E button, you could just replace it with the quantity, parentheses 2.714, right, because that's E, and then you could raise it for this first one to the 0.07, right? Enter, and then multiply by 750, and you get the $804.38. Okay, for the next one, if we're seeing how much money he would have in 10 years if it's continuous, we plug in 10 for the t. So we do 0.07 times 10, e raised to that value, multiply by 750, and you get 1,510 and 31 cents. And then lastly, if we're trying to see how much money we have in 25 years, we plug 25 in for t. So 0.07 times 25, e raised to that value, multiply them by 750, you get 4,350.95. Why don't you just plug it into your calculator to double check to make sure you're getting the same answer? And we want you to plug it in to make sure you're getting the same answer, really just to make sure you're doing order of operations, because that's where people go wrong sometimes. So last part C, how long will it take for your investment to double? Okay, so if we know it's a continuous formula, if it says how long will it take, we're trying to find this t, right? How long will it take for your money to double? So we're trying to find this final amount. We want it to end up doubling. So if your initial investment was $750, for that to double, that's multiplying by 2. So that's why how we know that this A, the final amount, would be $1,500. So we know $1,500. We know that our P, our initial amount, is 750, E, which is a number, raised to the R, 0.07, T. There's only one variable, one unknown. So for this problem, right, we first divide by, we want to isolate E raised to the 0.07 T. So we divide by 750, send those cancel. 750 divided by, 1,500 divided by 750, we get 2 is equal to E raised to the 0.07 T. So for this problem, there's 2 ways you can do it. In your calculator, if you want to use log, you can look at the base, right? And you can do log base E on both sides. And log base E of E would cancel, and that's how you would end up with 0.07 T. And you know that log base E is natural log. And that's how we get up here. So natural log 2 is equal to 0.07 T, which is what you see here. Then you divide by 0.07, because it's 0.07 times T on both sides. And then when you do that, you would get T is equal to 9.90. So after really close to 10 years, your money would double. So you would need to watch your account for about 10 years for your money to double.